This is the continuation of lessons 11.3 and 11.5 on surface area and volume. This is about cones. So the definition of a cone, a solid that has one circular base and a single vertex. So it looks kind of like a cylinder in terms of being made with the base being a circle. However, it's more like a pyramid in terms of how it comes up to a single point at the top. That point is called a vertex. So terminology first. The terminology first. The height of a cone is the perpendicular distance between the center of the circular base and its vertex. So just like before with a pyramid, the height is literally drop in altitude from the vertex. It hits the center of the circular base, and that's your height. Now you still have a slant height also. So the slant height is any one of the kind of profile edges as you look around the cone. If you sort of think about, if you're able to stand up here on the vertex of the cone and you slid down the cone, that would be the slant height. So the slant height could go anywhere around you could go like this or like this or like this. You're going down the kind of the surface, the curved part of the cone. Okay, the radius of the cone. The radius is exactly what you would think. The radius of the cone is the radius of the circular base. And then, like I said, slant height is the same idea as slant height in a pyramid. So again, slant height and regular height are not the same. One more thing here, a cone is not a polyhedron. Because again, a polyhedron has to be made of polygons on all of its sides, and circles are not polygons. Okay, formulas for how you calculate surface area and volume for cones. For every cone, the area of the base, it's a circle, right? The base is always a circle, so the area will just be pi r squared. And then the perimeter of the base, again, it's a circle, so the perimeter of the base is 2 pi r or pi d. Okay, perimeter is the same thing as circumference when you're talking about a circle. The lateral area of a cone is the area of the curved surface. So it's the area of the cone that's not the base. So it's all of this area around the sides. Just like with a pyramid, the lateral area was 1/2 perimeter times slant height. But with a circle, the perimeter is circumference. So 1/2 circumference times slant height. So we have 1/2. The circumference is 2 pi r. The slant height is L. That 1/2 and that 2 cancel each other. So it becomes just pi r L. Lateral area for a cone is pi r L. Total surface area for a cone. Lateral area plus 1 base. Okay, so the lateral area that we had from up there was pi r L. And then the area of the base, it's a circle, so it's pi r squared. For volume, the volume of a cone is 1/3 the volume of a cylinder with the same base area and the same height. So it's like you're doing area of the base times the height and then dividing it by 3. So 1/3, the area of the base is pi r squared because it's a circle times the height. Volume is 1/3 pi r squared times height. Now, you want to make sure you know the difference. In the volume formula, you're using the normal height. So for the volume formula, you're using the height that is the perpendicular between the vertex and the center of the circle. Whereas with surface area, you're using the slant height, which again was this length along the edge there. That's your slant height. So just keep in mind there's two different values. So for the first cone here, the radius is 6 feet. The height would be this perpendicular segment right here. Since we don't know the height, we're going to have to find it. So we'll do h squared plus 6 squared equals 10 squared. 100 minus 36 is 64, which makes your height 8 feet. Or in other words, that's a 6, 8, 10 Pythagorean triple. We were given the slant height was 10 feet. Area of the base, pi r squared. Pi times 6 squared is 36 pi. And that would be in feet squared. Lateral area. Lateral area for a cone is pi rl. Pi times 6 times 10, 60 pi feet squared. Our total surface area will be the lateral area plus 1 base. So we're going to do 60 pi plus 36 pi, or 96 pi feet squared. And then volume, 1/3 base area times height. The area of the base was 36 pi. The height that we found was 8. That's 12 pi times 8, or 96 pi feet cubed. Don't let it bother you that these both came out to be 96 pi, because they're completely different units of measurement. One's in feet squared and one's in feet cubed. So it's not like they're the same surface area and volume because you're using different measuring methods. One more cone problem here. The radius, 8 meters. Height, 15 meters. Slant height is this length right here that we're trying to figure out. Okay, so that would be 8 squared plus 15 squared equals L squared. 64 plus 225 is L squared. 289 is L squared. And that's 17. $17 is your slant height. If you recognize that is an 8, 15, 17 Pythagorean triple. All right, base area, pi r squared. (64 pi meters squared). Lateral area. Lateral area for a cone is pi RL. Pi times the radius is 8. The slant height is 17. That's 136 pi meters squared. Surface area, lateral area plus 1 base. So our lateral area was 136 pi. We're adding on 1 base area. So 64 pi is 200 pi meters squared. And then volume is 1/3 base area times the height of the cone. 1/3 base area was 64 pi. Height is 15. So I'm going to take out the 3 there, and that's just 5 times 64 pi. So 320 pi meters cubed. 320 pi meters cubed.